Hello everyone, our paper is titled Robustness Evaluation of Stacked Generative Adversarial Networks with Metamorphic Testing. My name is Taha Wasim and I will be presenting this presentation. So what is Stacked Generative Adversarial Network? It is a model that allows text to image generation. This is done through training the network using a set of images and text analysis which describes the image, and hence the model is able to generate images based on a text description using a generative adversarial network and are completely fake. If you look at the image to the side, you will not be able to recognize any of the faces because these faces have been generating using a GAN or generative adversarial network and do not exist or are not real in nature to begin with. The StackGAN model learns features from the training dataset containing images through the images themselves and also the text description that describes these images. These features are defined using the text description, and some examples of these features could include color, head, tail, etc. Once trained, the StackGAN generates images by extracting and utilizing the features mentioned in the text description. It must be noted that the quality of the generated image is dependent on the training dataset, so the training dataset needs to be free of noise or artifact and of high resolution, which is extremely hard to collectivize. So what will happen if the training data contains noise? It is hard to use conventional software testing methods to test the aforementioned defect in training data. Metamorphic testing, however, is way better way to solve the problem when we don't have access to ground truth, which brings us to understand why metamorphic testing is so important when it comes to evaluating robustness of a GAN model. Currently, it is very hard to test generative adversarial networks. This is due to individuals being unaware of what the algorithm might generate. Furthermore, it is hard to verify that the images generated are indeed of high quality and fit the description of the text. Lastly, in order to verify this, human intervention might be required without metamorphic testing, which is very labor intensive to begin with. So how does metamorphic testing help in this case? Metamorphic testing tackles the problem of test oracle by cross-checking and generating automated test cases. It does so by allowing a comparison between two outputs generated from two different inputs or inputs that have some variation between them. Moving on to related work and findings, the first related work discussed metamorphic testing and autonomous driving, whereby a driving system encountered a lack of diversity when it comes to test cases and how it could be overcome using metamorphic testing. The second inspiration we had was MetaOD, which is a combination of metamorphic testing and image processing, which was highly utilized throughout the course of our study in various different ways. Following a sequential manner while applying metamorphic testing to evaluate robustness of a model was somewhat of a common occurrence between the related work, which basically starts off with defining the metamorphic relations based on observable relations between inputs and outputs, and moves on to producing test cases to verify the said metamorphic relations. However, we realize that this manner of generating metamorphic relations cannot be applied to GAN models, considering it's nearly impossible to calculate what images the model might be able to generate or is going to generate. Hence, this study proposes creation of metamorphic relations in an iterative manner, whereby metamorphic relations are continuously fine-tuned and tweaked based on previous results and findings. In this study, we chose StackGAN version 2 as the model of our interest. This brings us to the main research problem this study tackles. What form of evaluation methods may be applied to verify the robustness of StackGAN version 2 model in absence of ground truths? Which brings us to the three research questions this study answers. First, how to identify the metamorphic relations between the characteristics of the model and its robustness. Second, what methods or techniques can be used to evaluate robustness of the StackGAN version 2 model. And third, how do variations in training data affect the evaluation techniques identified through the course of the study? The dataset used for training the generative adversarial network throughout the course of our study is CUB 200-2011. The dataset contains images of various different species of birds, and some of the images can be seen on the screen. Now, the ideal scenario when it comes to a dataset for any network or machine learning model, the dataset must contain minimal noise and should be of high quality, as mentioned earlier as well. However, that is very hard to achieve in real. The evaluation metrics used throughout this research are inception score and qualitative evaluation. Inception score is used to evaluate the diversity and quality of the images generated, and so the higher the inception score, the more diverse and better the quality of the images, and basically so the higher the inception score, the better the results. Secondly, qualitative evaluation was done using human perception by eye, which was further quantified using Likert scale based on the quality of the image and the realism of the image generated. Shown on screen is the result for the self-trained Stacked GAN version 2 model, which is trained using the image dataset mentioned earlier without any changes made to the dataset yet. This inception score and set of images will be used as a benchmark for the rest of the study and testing. This brings us to the first metamorphic relation. As you can see, the test case 01 or TC01 has an added bird to the original image, and such a bird was added to each image within the dataset, and the system was trained using this altered dataset. For test case 01, the results are shown here. It must be noticed that the images contain a gray tinted effect whereby the colors have faded out in most of them, and this test case received a lower inception score when compared to the benchmark score mentioned earlier. For test case 01, we noticed a gray tinted effect and a decrease in the inception score. However, we were unsure as to what could be the main culprit behind this negative impact, shape or color. This led to the generation of metamorphic relation 2. And so for test case 02, instead of adding a bird, a tree was added to the entire dataset, and the network was trained on this new altered dataset. It can be noted through the result of test case 02 that the gray tinted effect has somewhat decreased and the inception score has increased a lot, which goes on to show that the shape of the object might have an impact on the overall generation of images. With the results from test case 02, we notice that the shape of the object does have an impact on the overall quality of the image generated. However, we were unsure as to whether this gray tinted effect would decrease even more if the objects were added only to a portion of the dataset instead of the entire dataset. This led to the generation of metamorphic relation 3. This helped create two new test cases. Test case 03, which has an added bird to 30% of the images within the dataset instead of 100%, and test case 04, which has an added tree to the 30% of the images within the dataset instead of 100%. From the results of test case 03 and test case 04, it can be noticed that the gray tinted effect has decreased significantly. Generally, the inception score has increased from the past test cases as well. However, comparing test case 03 and test case 04, we noticed that adding an object to a selected portion had more impact on dataset with an added bird compared to the dataset with an added tree. From the previous test cases, we could evaluate that the shape of the object has an impact on the generated images. However, we wanted to understand whether the color of the object has a similar impact or not, considering that the test case with added tree had a better inception score, considering added object in that case is mostly green, while the test cases with added bird could have birds varying in color. This led to generation of metamorphic relation 4. This led to creation of three new test cases. Test case 05 with a green bird added to each image within the dataset, test case 06 with a blue bird added to each image within the dataset, and test case 07 with a red bird added to each image within the dataset. Here we can see that the green bird has a lower inception score than blue bird and has more of a gray tint compared to blue bird. However, given the results retrieved from test case 01, we can see that there is not a huge difference in the quality of images and the inception score when it comes to the difference in color of the birds added for each test case. Hence, this goes on to show that color does not have a significant impact on the model or the quality of images generated. The common occurrence between the test cases generated through metamorphic relation 2, 3, and 4 were that all the objects added were minimally obtrusive. Here, we wanted to evaluate whether the low quality of the images or the gray tinted effect of the generated images is caused by the added objects being obtrusive in nature. This led to creation of the last metamorphic relation covered under the study, metamorphic relation 5, which led to the creation of the final test case, which had an added bird to each image. However, none of the birds were overlapping the already existing birds and hence were completely unobtrusive in nature. The result for test case 08 and the images generated through the dataset does not contain any gray tinted effect, so the gray tinted effect might be there due to the high number of obtrusive images in the previous test cases. Furthermore, it must be noticed that test case 08 had a better inception score than test case 01, which was the first test case and introduced minimally obtrusive images of the birds to the original dataset. So first, it can be seen that the result for all test cases consists of a gray tinted effect except test case 08, which had unobtrusive bird added to each image within the dataset. Secondly, there is not a huge difference in quality and inception score of test case 05, test case 06, and test case 07, which had a different color of the bird added to the dataset. Lastly, even though test case 08 has no gradient hinted effect, it does not have a significantly higher inception score than some of the other test cases. This could be because the gradient hinted effect is only applied because of the nature of the object added, whether obtrusive or unobtrusive. But this does not have an effect on the overall diversity and quality of the images generated, and hence there is not much difference when it comes to the inception score. It can be seen that test case 01 and test case 02 had a lower inception score than test case 03 and test case 04. However, it can also be seen that reducing the size of the portion on which the object is added had more of an impact on the dataset with added birds than the dataset with added trees. This can be seen as the difference between the inception score of test case 01 and test case 03 is greater than the difference between the inception score of test case 02 and test case 04. Here we can see a comparison between test case 05, 06, and 07, with each having a different color of bird added to the dataset, green, blue, and red. It can be seen that generally there is not a huge difference between the inception score of the three test cases, which goes on to prove that color has little to no impact on the inception score of the images generated through the model. In conclusion, the paper contributed to generation of 5 metamorphic relations that may be applied to any text-to-image synthesis model. The paper proposed an iterative process model for generation of metamorphic relations. And lastly, the aforementioned behavior of stack conversion 2 was revealed with identification of metamorphic relations that can help build a more robust image synthesis model. For future research, test cases could be implemented with a dataset that contains images that are more real and natural. Future studies could also design an automated metamorphic testing process and investigate further on the effect of the shape of the added object on the model. The effect of the color of the added object on the stack conversion 2 model can also be investigated further. And lastly, future research should attempt to incorporate text input modifications into metamorphic testing when it comes to the stack conversion 2 model or image synthesis models. Thank you very much for listening to this presentation.
Yep.
Okay, I think the question and answer session is started, and thank you very much for the interesting talk. And here, I have a few questions about your MRs. I'm kind of interested in your MR. So you mentioned about, for example, in MR1, you mentioned about the data set up relation is about the data set which should not drastically affect the IS, the value, the metric. So how do you define that not affected significantly? Do you have a range about the fraction?
So we actually base it on the inception score. So the inception score is actually a typical matrix used in generative adversarial network to evaluate whether the image that is being generated by the model, does it mimic the real images. So we use the inception score as a matrix to define whether or not adding the extra objects into the image, is it going to affect the quality of the fake image that is going to be generated by the model or not? So that is how we actually sort of like form the first MR. So at first we try to include a small bird, just a tiny bird that we try our best not to block the focal object, so that we are trying to see if this by adding all these small images, small artifacts, would it actually affect the inception score of the image? So if you're talking about the value, the threshold, there is no real guidance or guideline to say how much of an inception score is the best or how much is poor or okay and so on. But rather we use we use the clean images as the benchmark. So from clean images, the inception score that we achieve is about 4 point something. So we use that as the ground truth or the benchmark to benchmark against the images that we generated by inserting the artifact objects.
And what about your output? So if the IS value for the output is under what value, and then you consider it as a wrong image?
at two things actually. We not only look at the inception score. So inception score does give us a quantifiable value, but we also visually inspect the image that is being generated. So when we found that when we add just one tiny small bird into the image, there is a grayish tint on the fake image that is being generated by the model. So this grayish tint was not something that we expect. We in fact even informed the original author of this stack gun paper. We informed them about this thing, and they were unaware of what is actually causing the grayish tint. So in some sense, we actually help review some of the bugs in the model, where the original authors are not even they don't realize there is such issue in their model. So yeah, we look at two things. First, the inception score. The second thing we look at visually, we actually visually inspect the images to see if there is any morphing of the images, if there is any weird contrast of the images, and so on. So we found that by just adding one small bit, first of all, inception score is about 20 to 30% lower. Second thing is there is a grayish tint on the images. The third thing is that the birds that is being generated, all these fake images, they start to form different weird artifacts. Some of them are even not recognizable as a bird itself.
Okay, so you mentioned about the gray tint. So is this an issue that have been observed in your experiment, or an expected output relation? Because I see that you put this relation, like for example, in MR2, you said output relation is like should result in a green tint in fact, but it seems that it's a kind of issue that have been observed by your experiment.
So the way how we come up with the MR is that we don't set all the MR in advance. We actually define new MRs based on the result that we have got. So when we define MR2, it is based on the results we got from MR1. So from there, we start to come up with new MRs to sort of like find out what is the main reason why there is a grayish tint. That's why in MR2, instead of adding a bird, we try to add some background noises. Like for example, in our case, is some trees to block some of the images, but it still doesn't block the focal image. And when we found that we add the tree object, it still create a grayish tint. That's why we follow up with more MRs, MR3, MR4, MR5, and so on, to find out what is the root cause of the grayish tint in the image itself.
So now I understand. You generate the following MRs according to the observation from the first MR, right?
Yeah.
Then my question is, how do you tell that whether this observation is really a normal behavior of the model or of the software, or an abnormal behavior? Because we observe something, it could be an issue, right? Be an issue, or it could be a normal behavior. And then if it is a normal behavior, and you can use it as a hint, or it can inspire you to get an MR.
Yeah.
What if it is an issue itself, and then how did you tell this? Or you just send the problem to the author and ask the author to
that is actually good. That's a very interesting question. So we are also, at first we will also question ourselves, are we really running the experiment right? Why there's so many great tinted images? Are we setting up something wrong? So what we have tried to verify is that we try to rerun the stack gun model a few times without introducing any artifacts at all to the training images. So of all the, I think more than 10 times we have run it, we found that there is absolutely no gray tinted image on the generated image at all. So we also try to verify with the original author. They also tell us that they didn't find any such issue before. And we try to find any discussion on the GitHub page of the paper itself. We also couldn't find this problem as well. So that helped us to trigger more and more a metamorphic relationship to help answer what is actually causing this issue. So I think one of the contribution that we have made for the metamorphic testing research community is that we could potentially design metamorphic relationship in an iterative manner instead of defining it at first, so that it can help us to provoke more questions or more ideas in terms of the metamorphic relationship to find out what is the root cause of some of the problem that we have found.
Yeah, great. And it's an interesting idea to get MR, because sometimes we don't have any idea. Maybe if we run the software and we can get some, and we have some understanding about software, and then we can know what kind of MRs that we can design.
Yeah.
If you don't run it, and we have no clue about how it actually behaves, right?
Yeah.
During particular.
So in fact, afterwards, we even try with different colors. So in MR4, we actually try different color. We try to change the color of the bird, the added artifact to red color, blue color, green color, and so on. And still, the gray tinted image is still visible. So at the end, we found what was the root cause. It was actually in the model, the stack gun model, they actually have a bounding box when they try to identify what is the focal object that the model is trying to learn. Okay, so when there is any artifacts that is blocking the bounding box at all, it will actually cause a gray tinted image. So this bounding box might not be really visible with visual inspection. So it's a square image. So even if the focal bird, we didn't really block the focal bird, and if the added bird is within the range of the bounding box, it will actually create this gray tinted image, because the bounding box will assume that everything inside the bounding box is the focal image that the model needs to learn. So that sort of help us to solve the problem, or help us answer the question why there is a gray tinted image that is being generated. Yeah. So I would say that this series of metamorphic testing and creating follow-up metamorphic relationship help us to address the issue in a very interesting way. Yeah.
I think it's interactive way, and a very novel idea for generating MRs.
Yeah.
A very interesting topic, and I think we are we're running out of the time, so maybe we need to finish this in like 10 seconds. So, to every attendees, you can move to the discussion room, and for further discussion.